we can actually calculate the amount of energy that is transferred when a physical change occurs. In this video, we're going to learn how to calculate the amount of energy transferred when the temperature of a substance changes, and we're going to do a slightly different calculation to find the amount of energy transferred when the phase or state of matter of a substance changes. Let's start with temperature. The amount of energy transferred if temperature changes depends on how much the temperature changes, right? More energy to make the temperature change more. What the mass of the substance is. If we want to change the mass of a small thing, it takes less energy. If we want to change the temperature of a small thing, it takes less energy than to change the temperature of a large thing. And it also depends on what the substance is. Some substances are easier to make the temperature change than others. So the temperature change is called delta T. This is the Greek letter delta. Sometimes it needs to be calculated from the final temperature, the temperature at the end, and from that we subtract the initial temperature. That means that sometimes we have a negative number for delta T, and that negative sign is important. Mass is referred to by a small letter m. It's measured in grams for our problems. The substance, each substance has a property called specific heat, which is represented by the letter C, and C is determined by experiments. It's different for different substances, and for many substances you can look up C, or the specific heat. So when the temperature of a substance changes, the total amount of energy transferred equals the mass of the substance times the change in temperature times the specific heat. Q, energy transferred, equals mass times delta T times C. Here's an example. How much energy do we need to raise the temperature of 200 grams of water, that's the mass, by 30 degrees Celsius, that's the temperature change? The specific heat of water is this number right here. Amount of energy needed equals mass times delta T times C. Here are the numbers with their units of measure. Here's how the units of measure cancel out. And we do the calculation, 200 times 30 times 4.18. There's 25,080 joules transferred. Joules is a unit of measure that's used to measure energy. All right, there's another example. How much energy is released if 50 grams of water is cooled off from this initial temperature to this final temperature? Again, the specific heat of water is 4.18 joules for every gram degree Celsius. Here's the calculation of delta T. In this case, delta T is negative. That's important. The amount of energy transferred equals mass times the change in temperature times the specific heat. Here are the numbers with their units of measure. Here's how the units of measure cancel out. Our final answer is in joules. That's a unit of energy. And the number is minus 6,270. The minus sign tells you that energy is released during this process. Energy goes out. Let's talk about a phase change and how we can calculate the energy transferred during a phase change. It depends on mass. It takes more energy to change the phase of something that's big than something that's little. And it also depends on what substance it is that we're talking about. Mass is designated by the letter M. It's measured in grams for our problems. And for each phase change, substances have something called a delta H, which is usually referred to as heat of a phase change. These are determined by experiments, and there are different delta H's depending on what the phase change is. So when something melts, we use the heat of fusion. When it freezes, we use the heat of solidification. These are the same number, but they have opposite signs. When something boils or evaporates, it changes from liquid to gas, and we use heat of vaporization. When it changes from gas to liquid, we use heat of condensation. These two have the same number, but opposite signs. Energy transferred during a phase change equals the mass of the substance times whatever the heat of the phase change is. Q, heat, or energy transferred, equals mass times delta H. All right, here's an example. How much energy is released if 20 grams of ice melts? So the heat isn't actually released, it's actually required, how much heat is required. So the heat of fusion of water, the heat associated with melting a gram of water is 334 joules per gram. The heat transferred equals mass times the heat of fusion, 20 grams times 334 joules for every 1 gram. Grams cancels out. Here's our answer. This energy is not released. It needs to be put into the ice to make the ice melt, and so the sign is positive. Now here's an example of how much energy is released, and this time water is freezing. 50 grams of water is freezing. The heat of solidification of water has the same number as the heat of fusion, but the opposite sign. Here's the formula for the amount of energy that is released. Here are the numbers and their units of measure. Here's how the units of measure cancel out. Here's our answer. The negative sign tells us that energy is released. J, or joules, is a unit of measure for energy. You can watch this video to help you with your quantitative problems. Stop at any time if you need to look closely at an example. Over and out.